Okay. Yes, once again, very good morning and thanks for joining. In continues to yesterday's session, yesterday we just started learning about how SQL Server Architecture will works. Okay. Primarily, we started the database engine. So we know we are having multiple components. Out of that, we started mainly database engine. In the database engine, the majorly two components are available. One is relational engine, one is storage engine. Our main focus first will be these two along with the network. It's nothing but protocol. Rest we'll discuss slowly, okay, one by one. So what we discussed yesterday is regarding the network first. Okay, so protocols. So we are having in SQL Server, we are having shared memory, named pipes, TCP/IP. So these are the three major protocols are available in SQL Server. When SQL will choose the shared memory means when you are trying to access the when your client and server as part of the same mission, then by default it will go to the shared memory. Okay, so when your server and client is interacting via LAN cables, then it will go for named pipes that explicitly application team people will highlight to us. Now finally TCP/IP protocol. Okay, it is a widely used protocol. If you want to connect SQL Server remotely, then it definitely will go for the TCP. And what is the default port number of TCP/IP? 1400. That's what yesterday we discussed, and we discussed about the network packets. So how the data is transferring from client to server, server to client again back means in the form of packets. Okay, in the form of network packets, and it is in the encrypted format only. It will encrypt, it will decrypt, it will decrypt, it will encrypt. Okay, that is what we need to understand. In the form of network packets only, the data is transferred. We'll see today. Now, that's what first we discuss, and one more component we discuss is okay. So the major part. See, not this one. Let's go back. So here we discuss. Okay. Now, in addition to that, what we are going to learn today is okay. First, see when you are performing either select or insert or update or delete, whatever you are doing in SQL Server. Okay, whatever you are doing in SQL Server. First, what will happen? Okay, first what will happen? It will first the user will try to authenticate via network protocols. Okay, via network protocols. SQL Server network interface establish the network connection through the network protocols. First, it will establish the connection using shared memory or named pipes or TCP/IP. Okay, in the form of TDS packages. In the form of TDS packages. That's what yesterday we discussed. Once it establishes the connection, now what will happen? Now your connection will need to get some resources. Now how the resources are getting on top of entire database engine, there is a one layer called SQL OS layer, SQL operating system. Like operating system, like SQL is also contain one operating system that technically we are calling as a SQL OS. SQL OS. Now SQL OS will generate one SPID, nothing but session process ID. See, SQL operating system assigns server process ID, that is nothing but SPID to incoming the traffic. So you will get for your session, whatever you are doing for your session, SQL Server, SQL OS will generate one SPID. See, this is what, okay, 89, 66. Now, when you open one more connection, so you will get 51 session. When you open one more connection, 63 session. When you get one more connection, 64 connection. So you will get one session ID, server process ID, or whatever you can call it, SPID. Okay, so this SPID can get some resources. So when you are processing something currently, this is nothing. It is a empty. We are not doing anything. We just open the connections, but nothing is doing here. But when you just started doing some activities, so SQL Server will start allocating the resources in the background. Who is going to allocate the resource? SQL OS is getting the resource in terms of memory, in terms of CPU, in terms of IO. SQL OS is getting the resources for your session. So once you got authenticate, Once you got the session ID, then our activity will start. Then our majorly primary will start. Getting my point till now, everyone clear? So what is happening first? First, you are trying to authenticate via network protocol, and on top of that, you are getting the SPID from the SQL OS. Now you will start your activity. What you will do? So whatever operation you are going to perform, like either insert or update or delete, whatever you are going to do, let's start your activity via relational engine. Then it will go for storage engine. Nothing but in the database engine, primarily we are having two components, right? One is our relational engine, one is our storage engine. First, it will go to the relational engine. So till now, any questions? Everyone clear? How you are getting that SPID?
So Subbu, I have a one question. In case of shared memory, we protocol, does it comes to the network layer?
Yes, it is also network layer only, right?
No, I don't. It's at that time there will be the communication in between the memory because they are in the same server.
See, shared memory is also part of the network protocol. Okay,
Okay.
shared memory is also part of network protocol. Okay,
Yes.
but when it will use the shared memory means within the same server. Your
So, but
client.
they are not using any port for the communication.
No, it's not using anything. No, nothing.
So that's why I'm saying that it uses the memory for communication. So how it will comes on the network layer?
See, memory. See, I can give you one simple example. You remember when we are discussing clusters?
Yes.
Clusters. There is a nothing but there is a call heartbeat, like look alive, is alive. What is the
Yes. Yes.
concept of is alive? What is the concept of is alive? Every
It's
60 seconds, it will try to
yeah.
perform select at the rate server name, and whatever the output it received, it will stored in the memory cache. Which protocol it is using? Shared memory protocol only. How it is communicating, how your Windows, okay, RHS.exe file is interacting HADR.dll. How it is interacting via shared memory, because these two are in the same. Once it interacted, whatever the output it received, that is going to stored in the shared memory. Means memory. See, memory. Okay, so
Okay.
technically we are calling as a shared memory.
Okay.
I hope you got my point. There is a network
Yes.
protocol, sir. Nothing but shared memory is a protocol, network protocol. And technically speaking, there will be cache also. Whatever you told is also right. I'm not telling wrong, but it is a protocol first. It's a network protocol. If I want to communicate, definitely I need to use any one of this protocol. If I stop all this protocol, entire my SQL will goes down. I will do it, sir. If I stop all the protocol, my SQL will down. Then why? See, as our point of us, for example, if it is not a, if my client and server, if my client and server is not in the same mission, of course it is in the same mission. Okay, it is using the shared network protocol. Our understanding is a shared network memory. No, these are the protocols first. If you stop all the protocols, entire your SQL will goes down. You can't start the SQL. You can't start the SQL. So this is a network protocol, and there is a memory. See, our focus will be data cache, plan cache, okay, log cache. There are n number of caches in the buffer, Raj. There are n. Out of that, shared memory, which is using some sort of information which is storing in the background for us. Yep. You got it? No? Yes.
Yeah. Got it. Thanks
Okay.
for
Yeah. Yeah. Good question, sir. Actually. Now, any questions so far? How you are getting that session ID? How you are getting this session ID? SQL OS. SQL OS is generating this session ID. Your database engine on top of the database engine, there is a layer called SQL OS, nothing but SQL operating system, who is going to talk to your Windows operating system to get the resources. Now, who is going to generate this SPID? SQL OS is going to generate the SPID. We'll talk, sir, more, no worries. Now, once you got everything, now you started. Now, see, first it will go to the database engine, as I told you yesterday also. Once it go to the connect to the SQL, our major primary is the database engine. Under the database engine, we are having, see, when this is our primary database engine. Under this engine, we are having relational engine and storage engine. Our first focus will be relational engine, then we'll focus in the storage engine. Let's go to the relational engine again, once again. Okay, just go to now. See, in relational engine. So see, database engine is the main, sir, entire your processing, everything. Okay, everything it is processing database engine. But relational engine will process only query. See, the relational engine is sometimes called as a query processor because it will primary function is query optimization and execution it contains. In relational engine, there is no data. In relational engine, there is no data. Please just keep it in the mind. There is no data. There is no data. So now, once your query came to the relational engine, the first primary component is the command parser. First primary component is the command parser. So what exactly it is doing? Relational engine parsing. So it need to parse. What do you mean by parsing? Yesterday we discussed it. It will check the syntax text. It will check the semantic text. Check. Okay. It will bind the query, prepare the query tree, and verify any plan is available or not. In case any plan is available, it will use the same plan for that query. In case there is no plan, okay, it will try to prepare the plan from the optimizer. Optimizer will start the preparing the plan. Okay, and finally it will go to the executor. Executor will start executing the execution plan. So that's what yesterday we talked. Let's go to the next slide, sir. See, check the query to make sure that syntax is valid. If the query has a syntax error, then it will error in the return the client through the protocol layer. First, it will check the syntax. This is the mandatory. In case any syntax error, it will again go back to the customer and saying that there is a syntax error. Okay, there is a syntax error via network protocols only. If the syntax is a valid, the command parser generate the parse tree and give to the algebraize. This is very important. What is this one? Semantic test. Yesterday we discussed that semantic test means nothing but it will try to validate whether the tables, columns which you used in the query existing, loading the metadata information related to the columns, identifying all the data types, the values, everything. So here in the semantic test, what exactly it is doing? It is trying to get the information related to your query. Means what are the tables you involved? Means how you would design the query. See, for example, this is my query. What is the table? Here is a column. This is the table. Okay, whether this table is existing on the database or not. Okay, whether these columns are available, their data types, okay, metadata related to that table, everything it will try to grab the information. Who is going to grab the information? Once your syntax check is done, once parser is done, next it will identify all the information. Then finally, it will try to start preparing the query tree. So phase by phase will go, sir. Whatever we discuss here, okay, whatever we discuss here. First, what it will do, it will just check the syntax checks. Next, it will check the semantic checks. Next, it will prepare the query tree. Can it do same thing? Reproducing the issue, everyone. So I'm just taking one simple example in the database called Adventure Work 2019. See, here there is a option called parse. Okay, if you go to the tools, go to the options. Okay, go to the okay, query execution, SQL Server, general, advanced. There is option called set parse on only, parse only. Okay, either you can enable parser only here, either you can choose here. Mostly we won't enable here, sir. What we will do, we will directly write the query, whatever you desire, you will write the query and you will just click on parse. Now it will check, sir, your command completed successfully. Command completed successfully. See, try to understand the logic about parsing and validating the query. Both are little different, sir. Now see, for example, if I run this query, I will get some result. Okay. Oh, being the parse is enabled, I'm not able to see the data. If I copy this one, if I go to the query, if I run here, oh, tool options and check this one. Okay. Now let's execute. Okay, I will get some result. Whatever I'm looking, I will get some result. Now see, now very important point here. I don't know what columns are available in this table. Okay, in this table, I don't know what columns are available. For example, I wanted to see what columns are available. Okay, sp underscore help, and you need to pass the single quote as the table name, sir. When you execute it, you will get complete information about the table. You no need to go to the database, tables, okay, tables and extend the table where it is available, sales order details, okay, sales order details, enable the columns, enable the keys, enable the constraints, enable the indexes. I don't want to do all this stuff, sir. Very simple. If I wanted to get some insight about the table, okay, this is very important. Okay, please remember sp underscore help table name. Okay, when you run sp underscore help table name, you will get information about your table. What is your table name? Who is the owner? This is a user table. When you created, along with this, you also getting the information about the columns. Columns, their data types, okay, their length. This is very important, sir. Okay, this is very important. I will talk more on this indexes. When we are discussing indexes, I will talk more this. Okay, this is the one thing, and this table contains the primary key. Okay, along with that, you will also getting the information about the indexes. This is one very important. Okay, I am also having the indexes on this table. Currently 3 indexes are available. Now you are getting this much of good information when you run sp underscore help. Now see, I am writing a column here, comma. So for example, I'm just writing a column. For example, I am just writing a column here, test. Okay, is there column is available here, test column in this table? No, right? No, right, everyone? Come on, sir, everyone try to understand. Okay, is there any column is available in this table, test?
No.
No, no. See, there is no column called test. Now see, if I am parsing, my syntax is perfect, but there is no column. See, parser is not validating your data. Parser is just validating the syntax. Is it clear? First, everyone, your parser is not validating the data. Your parser is just checking the syntax, whether you properly written or not. So, for example, I not properly written. Okay. Now see, if I pass it, I got some syntax. See, incorrect syntax nearby keyword called from, because before from there is a comma. I just added a comma. It will just check the syntax sets. It won't validate the data. Means in terms of tables, in terms of columns, nothing. It will just check the syntax sets. It will just check the syntax. Now that is a parser. Is it clear? First point, everyone. No, yes. Parser will just check the syntax sets. In case if you written any syntactical error, it will throw an error. to the client. See, SSMS is also one client. SSMS is also one client. It is throwing error to us. What error? Incorrect syntax near near some keyword. Now, this is the first phase. For testing purpose, I written a couple of things. Okay, I can use. I can also use. I can go to the option here, enable the set parser only, or I can choose the parser here, or in SQL Server, there are set parameters. Okay. In SQL Server, there are set parameters. Again, sir, whoever watching the recording, make a note down all these set parameters in a separate page. Okay. You will get n number of things. So, for example, if I go to the Google, hey, come on, where is my mouse? Okay. Yeah, shit. 1 second. Close it. So, if I go here, these many set parameters are available in SQL Server. See, these many set parameters are available. Set statistics on, set statistics time on, set statistics XML, set statistics row plan, set statistics row count, quoted identifier, okay, parser, offsets, no exec, okay, log time mode, languages, okay, FMT only, okay, date first. So we are having ANSI values, ANSI padding. There are many set parameters are available in SQL Server. So out of that, today we are going to discuss parser only. So when you run this query, it will just parse us and it will share the output to us. So if I'm just passing something here, okay, something here, now it will just syntax is right. Our syntax is perfect. Our syntax is perfect and it is displaying your syntax is good. Now next thing is our semantic test, right? Next thing is our semantic test only, right? Once our syntax test is done, now it need to find whether the tables, columns used in the query exist, loading the metadata information related to columns, identifier, all the things it need to identify, right? Semantic test need to do, right? Yes or no? Everyone. Now, how it is doing? For that, I am going to show you one more example, sir. FMT only. Basically, we won't do in real world again. Again, sir, we won't run all these commands in real world. This is just for our understanding purpose in the initial phases. Okay. Now I wanted to check the semantic checks. Now, what I am going to do, I am running a select statement. Okay. I am running a select statement. Okay. Copy this one. Go to here, sir. Go to open new window. Now execute that. See, invalid object name. There is no object called test. There is no object called test in my database. See, anywhere you will see the table name called object test here. Nothing. Nothing. So you are clearly getting invalid object name when you perform this. While once command parser check the syntax, next it will check the semantic checks. Under the semantic checks, it will identify the column, table, data types, all the stuff. Okay. Now it will throw an error like so invalid object, invalid column name. Getting, not getting, everyone. So now let's change something this query, sir. Okay. Says if not understanding, highlight me. Don't listen blindly. Okay. For example, I am using okay something from the query. Now see invalid column name. Invalid column name. This is the semantic test. Is it clear now? What is the semantic test? What exactly it is doing? Parser is something different. Semantic check is something different. Okay, don't clumsy both. Okay. Directly, can I do semantic test, Subbu? Means no, you need to use this set parameter, sir. If you wanted to check whatever the things you are going to return, okay, if you want to check. So, for example, not only this one, sir, let's make star only. I can use, okay, where class, okay, where, um, what is that column name? Sales or the details ID equal to at the rate. uh, sales ID. So for example, if I'm passing any parameter, oh sorry, spelling, sales ID, for example. Okay. For example, I am using a parameter. So how I can pass a parameter to this column? This is my column. I am passing a parameter. Now if I run this one, okay, see, must declare the scalar value. So it is, that's what. Semantic checks, it will verify everything, sir. Not only column, it will verify tables, it will verify columns, it will verify whatever the declaration you done, it will verify the parameters, whatever you are passing. Got it? No. Yes. About the semantic checks. Everyone clear? Can you do can you do this in real world Subumis? No, sir. Say seriously, I'm saying I never run all these queries in the because we are not designing any queries. Who will design the queries? Application team will design it, they will run the queries, sir. But as a DBA, we wanted to understand about what do you mean by semantic checks, Subumis. This is how you can test it. Okay? Perfect, everyone. Come on, sir. Everyone is so silent. Saturday.
Perfect.
Okay. Just
So,
bear with me. Yeah.
so table level permissions when it will check,
Sorry.
like that query is executing, that the user has the permission, has the uh, I want to know when the user level table level permission will it check on the which layer?
Execution, right? In terms of executing. Okay,
Yes.
see, I can do one thing for your clarity. Good question. I don't want mislead the question, okay? I can do one thing. Let's create one login, sir. But just for to clarify, okay? Because we are learning, okay? We should not provide some
Yes. Yes.
junk data. Okay. Just I'm granting public. Means the test user can connect to the SQL.
Yes.
Test 1, 2, 3. Connect to the SQL. Okay. And he can access the database, execute it. Hmm. See, in the semantic, are you getting my point?
Yes. On the summit. Same
Yeah.
thing.
See, we don't want, sir. See, if there is a question, literally we don't know. Okay. Just go and run. Don't run in real world, sir. Run in your laptop. Okay. Please don't run anything on your real world. Okay. To do some experimental, you can do in your laptop also. So permissions are also checking in the semantic checks only. Okay, permissions along with the tables, columns, metadata, data types, all the information is checking the in semantic checks. Once your semantic checks is done, then what it will do? It will start preparing the query tree. It will start preparing the query tree. So how I can see that query tree, Subbu? Once my syntax is fine, my semantic checks is fine, everything is fine. Now SQL Server is generating the query tree. Now I wanted to see that query tree, Subbu. Okay, especially sir in real world, don't execute all this traces. Okay, that is not a best practice. We should not run any traces in real world until unless we got approval. Okay, don't run any traces. For practicing purpose, you can do everything on your laptop. Okay, please make a note down. Oh, Subbu told that okay, we need to enable these traces to see the query tree. What is happening in the query tree? No, don't do all that stuff, sir. Okay, please just make a note down. This is for our testing purpose. Okay. Now I am running this. I'm just running this query to get the query tree information. I am enabling 3604 trace file. I am enabling 8605 trace file. I am passing some query hints here. No worries. First time who are listening, we will talk more on the upcoming sessions. All this stuff. Okay. Now when I run this query, okay. Come on. I will go here, sir. Okay, it's good. Now go to the messages, sir. You will see complete the query tree. Complete the query tree. Now you will see the query tree. Everyone able to see the query tree? No? Yes?
Yes.
How the query tree is generating in the background. How the query tree is generating in the background. Like see, there is a website called SQL Parser. Okay. So for it's a simple, sir. I wanted to get some answer. So assume you are learning first time SQL. You don't know anything about development also. For example, assume all are learning first time. We don't know anything about SQL. Queries, how to design, how. Sir, one second. One second, sir. Yeah, I'm back, sir. Sorry. Everyone able to hear, right? Just confirm me once.
Yes.
Yeah.
Yes.
So for
Yes.
example,
Yes,
for example, we wanted to see how the query tree looks like, okay? And we don't have much idea. In real world, we will see all this stuff. So means no, basically, many times no. But I wanted to get some insight. Like for example, if I open the select statement, okay, this is my query. Okay, it contains subquery. Like see, it contains two columns within. See, there is one table T1, and you are getting finally three columns. But please make a note down. There is one more query in the same select statement. There is one select statement. There is one more select statement. This we'll call it as a subqueries. Okay, subqueries. So within the select statement, there is one more select statement, and they are calling as a column in the here. For this type of query, how the query tree is generated means. So if you go here, you will get complete information about your query tree. Okay, so what are the attributes, what are the text, what is the elements, what are the columns you are going to use? It will completely generate the query tree internally. Okay, internally it is generating what sort of query you are going to use, you are using currently, what sort of query you are using, and for that query tree, how many columns, what are the tables, join conditions, based on your query, how complex query you design. Based on how complex query you design, SQL Server will start preparing the query tree. Now you will get one doubt. Okay, it is preparing some query tree. Okay, it is preparing some query tree. Will it is storing somewhere? Will it is storing somewhere? This query tree, it is preparing query tree. Will this query tree store is saving somewhere? Like that when we are talking the using the presentation, oh, there is a plan cache. So our plan cache are storing somewhere in the memory. In the memory, your plans are storing. Now my question is, you are saying that query command parser is preparing the query tree. Command parser is preparing the query tree. Will that query tree is storing somewhere for our future reference purpose? Yes, it is storing. Yes, it is storing. Where it is storing? In the memory. If you go for select star from from this dot dm underscore os underscore memory underscore plus. Okay, plus there is object. Okay, cache store cp. Okay, see, cache store object cp. Okay, cache store object cp, cache store SQL cp, cache store phdr. This one, phdr. This is storing the tree information. Okay, there are clucks. There are almost 378 clucks are there in SQL Server. Memory clucks. Okay, memory clucks. Will I need to learn all this, Subhi? We can't understand what exactly everything is doing. At least we will learn when we are discussing memory architecture, memory troubleshoot. At least we'll learn top 10 clucks. Okay, when you are going to troubleshoot, especially in memory, these top 10 clucks will help us a lot. No one knows what all this clucks are doing, sir. Okay, don't think we need to learn many things out of that. Clucks is very important when you are dealing with a memory. Okay, out of that, where your query tree. Okay, now your query tree is generated. Okay, where that query tree is storing in the SQL Server means there is a cluck called PHDR cluck, cache store PHDR cluck. In that cache store PHDR cluck, your query store in query tree. Sorry, not query store. Yeah, come on here. Query tree information is storing. So once your syntax checks is done, once a semantic checks is done, then it will try to prepare the query tree. That query tree information is storing in the cache store PHDR cluck. In the cache store PHDR cluck, it is storing. Okay. Now once your query tree is done, now that query tree will move to the optimizer. Optimizer. This is the one of the major component in entire database engine. In entire relational engine, optimizer is the key component. Optimizer is a key component. Very important. As of now, just we are discussing only 5 minutes, but we will discuss more in depth in the upcoming sessions. Okay. Optimizer will plays a major role. Please keep it in your mind. Optimizer will start preparing the execution plan. As you remember yesterday we talked, right? If you are planning a vacation with your family, definitely you will prepare some plans, right? One or two plans, and you will finally will choose which is the best plan in terms of cost, in terms of safety, in terms of protection. So which is the best plan you will choose. Like same, optimizer will also prepare the execution plans. Once it start preparing the plan, it will choose the best plan based on the cost. Always the cost is very important for us. Money, for human beings, money is the cost. For SQL, cost in the sense CPU, memory, IO, all this, right? Okay, the cost. Now once it's prepared the execution plan, see, this is how it will prepare. For example, this is how it will prepare one plan. This plan, where it will store, it will also stored in the where it triggered. Oh, sorry, this will store in the, okay, cache store SQL CP, cache store object CP. So there are two kind of requests will perform. This is a ad hoc kind of request. This is a ad hoc request. I am simply writing one select statement and I am executing. That is the ad hoc request. Or you will design the stored procedures. Means here two kind of things. Programmability. You will write the stored procedures. You will write the not user developers. Okay. So what kind of query you are executing, whether it is a ad hoc request or it is a programmatic. Based on that, your caches will be stored in the cache stored object CP, cache stored SQL CP. Is it clear, everyone? So your plans are storing, your query tree is storing, it is validating your data, it is also checking the syntax. Once the plan is ready, then it will try to go to the executor. Based on what Subbu it is preparing the plan means based on the selectivity, based on the cost. Based on the selectivity, only remember these two terminologies, sir. In the upcoming class, we will get more clarity on the optimizer. Don't think little more, okay? Is it clear, everyone? No? Yes? Questions up to this? Okay, now, once the plan is ready and go to the executor wants to execute the data, but there is no data in the relational engine. There is no data in relational engine. Now what it will do? Executor will send request to the storage engine via OLDB connection. In the background, it is establishing the connection using OLDB, and it will make a bridge between your relational engine and storage engine. What is that OLDB? How to establish the connection? Well, see, sir, all that stuff. Now see, your query executor will send request to the storage engine, okay, via OLDB connection. Now, in the storage engine, there are many components. This is all storage engine, sir. Okay, these are all components or belong to storage engine, like access method, buffer manager, buffer pools, data cache, plan cache, log cache, log cache, log cache. There are many caches are available along with the transaction transaction manager. So out of that, first let's focus on the select statement. Okay, I told you, right? First our focus will be select statement. Next our focus will be inserts, update, deletes. Means when you are trying to modifying the data, how our engine is reacting. First focus on the select statement. Now, once your plan is prepared and executor will start executing that plan, but there is no data in the relational engine. Okay, now what it will do? Executor will send request to the storage engine via OLEDB connection. It will make a bridge between here connectivity, and it will send request to the access method. Okay, in the storage engine, it will send request to the access method. So access method also doesn't contains the data. Access method also doesn't contains the data. Now, what access method contains? Access method contains multiple APIs. APIs. Okay. Application program interfaces. Application program interfaces where it can understand what sort of request you are asking to pull the data. What sort of request? Okay. User is requested. What sort of user is requested? How I need to process this one. So Microsoft designed multiple APIs internally, easily to understand. For us, technical terms to understand. So access method contains select statement, non-select statement. So select statement, select not sequence or select, non-select, non-select. What do you mean by select? Reading the data. What do you mean by non-select? You are writing the data, modifying the data, deleting the data, updating the data, anything. That comes into the non-select statement. So access method can understand whether you are going to perform select statement or you are going to perform non-select statement based on the APIs, inbuilt APIs designed by the Microsoft. Is it clear, everyone? No? Yes? Yeah. Now, once assume now I am going to perform the select statement. Don't sit idly, sir, everyone. Simply, if you're not understanding, okay, no use again if you're simply listening, okay, without understanding. Now, for example, I am performing a select statement. I told you that I am performing a select statement. Now access method understand, okay, user so and so user, okay, for so and so request he wants to read the data from so and so tables, so he can understand. Now access method is not having data here. Now what access method do? access method will send request to the buffer manager. Buffer manager is nothing but like kind of RAM. Simple for your understanding. Buffer manager is a RAM, sir. RAM. Okay. So you are having RAM, right? For example, in my laptop, I'm having 16 GB of RAM. So I will allocate 12 GB of RAM to SQL Server. Now this 12 GB technically we are calling as like a buffer manager. For example, now buffer manager is like a RAM. Okay, RAM. So in the buffer manager, we are having the buffer pools. Buffer pools in the buffer manager, we are having the buffer pools. In the buffer pools, we are having data cache, plan cache, lock cache. So there are multiple caches. Our first focus will be data cache. Okay. Plan cache is also very important. Rest we won't check that much, sir. But data cache is the most consumer in the RAM. Who is the most consumer? Data cache. Who is the most consumer in the RAM means who is the most consumer in entire buffer manager is data cache. Data cache. Even if you go here, when you are dealing with the uh, um, memory part, there is a one clerk, sir. Is a clerk. No, can do one thing. Uh, order by page KB descending. Okay. Yeah, this one. This is the most culprit clerk. Data cache is nothing but SQL buffer full clerks. Okay, this is the most culprit consumer, not culprit, sir. Most consumer clerk in the memory. Data cache. Okay, data cache. We'll talk more when we go to the memory architectures, all this stuff. Okay, as of now, don't think much. Now, what exactly it is happening? Your query executor will send a request to access method. Access method contains multiple APIs. Okay, multiple APIs to understand whether it is a select statement, whether it is a non-select statement. Now, access method sends a request to the buffer manager. Buffer manager contains the buffer pools. Buffer pool contains the data cache. Now, it will go and verify whether data is available. Currently, nothing is there. Now, what exactly it will do? There is a database, right? You have one database called DB1. When you create any database, you will get two files here. One is MDF, one is LDF. Okay, one is MDF, one is LDF. Now, being the data is not available in the data cache, it will go to the MDF, it will get the data, it will place one copy in the data cache, and it will send the request to the user. So what exactly it is doing? Your access method wants some data requested, whatever the user requested, you want to see some data. Now, currently, the data is not available in the cache. Now, what it will do? It will go to the database, get the data, place the data in the here in the cache, and sends the data to the user. Sends the data to the user. This is what happening when you are going to perform the select statement in the background. Select statement, only think select statement. When we are going for non-select statement, I will talk about transaction manager, log manager, all the stuff. Got it? When you are going to perform the select statement, what exactly internally it is doing? So first it will check the syntax, next it will check the semantic, then it will prepare the query tree, then it will prepare the execution plan, and it will go to the executor. Executor doesn't contains any data. Executor will send request to the access method. Access method can understand whether you are going to perform select statement or non-select statement. Being it is a select statement, access method request to the buffer manager. Buffer manager contains the buffer pools. Buffer pool contains the data cache. In the data cache, whether data is available or not. Currently, being you are running first time, there is no data. Now what it is doing? It is going to the database, get the data, place in the cache. Now it will send to the user. Okay, not okay. Everyone.
Okay, okay, sir.
Very, very important, sir. In a simple practical, I will show you, sir, in a simple practical to understand. Now see, my buffer pool is sitting my buffer pool is sitting little idle, like not that much size it is consumed. Okay, that much size is consumed. Now, for example, I can do one thing. Select that from sales dot sales order big table. Okay, I'm running this table. Now copy this one. Now my buffer pool is sitting on sixth position, sir. 6 to 7 position. Now when I run this query, oh, okay. This is the user of test. Okay, I can run it. See, my buffer pool is the top consumer now. See, earlier my buffer pool is sitting in the 12th position, 13th position, right? Just now. Agree, not agree, everyone? It is sitting at 6th position or 7th position. Now suddenly my buffer pool came into the top position. It is the most consumer because I am running little massive select statement. I am running little massive select statement which is trying to keep the pages in the buffer. Okay, now buffer is consuming a lot. If you now it is almost 451 MB it is consumed. Okay, see it is almost grown to 1.1 more than 1 GB the buffer is consuming. More than 1.2 GB. Okay, 1.27, 1.27. No, sir. No, it's not 1.27. It's a KB, right? Okay, let's remove this one. It's almost 12 GB. It consumes almost 12 GB buffer because this table is little massive table. This table is a massive table and I'm directly performing a select statement. Now see, I am stopping this one. Now you will see only SQL buffer pool is the culprit. Okay, not culprits, a consumer. Okay, SQL buffer pool is a consumer. Now I'm just using order by class. Order by. Okay, the people first time who are listening, you may get confused, but the experienced people, you can understand. Okay, I don't know whether you will deep dive in the memory like this. Now I am running the same select statement. Now see, on suddenly, you will get one more clock, which is the consumer. See, SQL query reservation clock is also consumer now. SQL query reservation clock is also consumer because I am using order by class. I'm using order by class and one more clock is a consumer now. That is nothing but SQL reservation clock. Okay, that is how we will monitor, sir, in the background when we are dealing with the memory. I hope everyone understood. No? Yes? Oh, let me stop it, sir. Otherwise, it will eat my memory like anything. Okay, let's stop. Is it clear? When I'm going to perform the select statement, what is happening in the background? Any questions? Do we have any control on allocating memory? Yes. SQL itself allocate to size of. No, we can have control to how much memory we can allocate to the instance directly. Okay, majorly we'll allocate to the instance level. It's not like object level. We won't restrict. No. Any questions, sir? Anyone? Understand high level hierarchy? So first it will check the parcel, then it will prepare the semantic checks, then it will go to the optimizer, then it will try to execute and retrieve the data and sends to the user. This is what happening. See, storage engine contains the data. Okay, storage engine contains dealing with the data. So access method contains only two. Like access method contains multiple APIs, but majorly for our understanding to simplify, like it kind of select statement, it kind of non-select statement. Based on these two, access method can interact. Any questions? Come on, sir. Everyone is so silent today. Why? Any reason specific? Ritesh? Everyone able to hear? Listen? No? Yes? At least.
Yes, sir. Yes, sir.
Okay. This is about select statements, sir. Okay. Now, let's talk some other components. Then I can go for writes. I'm not directly going for the writes, how inserts, update, deletes are happening in the background. Okay. Before that, I wanted to talk little different. Okay. I wanted to talk. See, basically in SQL Server. Okay. In SQL Server. Okay. In SQL Server, everyone need to understand. Let's okay. One SQL is a product. Okay, SQL Server is a product. And once we install, okay, where you will install any one of the VMs. Okay, means nothing but servers. Okay, it can be it can be Windows operating system, it can be Linux operating system. You can install the SQL product. You can install the SQL product. Once you install, we are technically calling as an instance. Instance. We are calling as an instance. Means this is one instance. This is one instance, sir. This is one instance. Okay, technically we are calling as an instance. Once you create the instance, our job is done? No. What you need to do? You need to create the databases. Databases. You need to create the databases. So once you install the SQL, is it our job is done? No. What you need to do? You need to create the databases. First thing, you need to create the database. Now, see, every instance will contains multiple databases. Every instance contains multiple databases, n number of databases. What do you mean by database? For your simple understanding, a database is a collection of data that is stored and organized, well organized. Okay, where you can store specific object related information. Okay, specific application related information you can store, and which is completely organized. Okay, and we can manage and we can access data easily. Okay, so what is the database? Database is collection of data only, but it is well stored, well organized, well protected, sir. Okay, assume definitely we need to create a databases. As a DBS, we need to create the database. Once you create a database, what is happening? What is happening, Subbu, means once you create a database, by default, two files will be created. By default, two files will be created. One is MDF file, one is LDF file. One is MDF file, one is LDF file. Two files will be created by default. By default, two files will be created. One is MDF file, one is LDF file. One is MDF, one is LDF file. What do you mean by MDF file? Master data file or primary data file. You can call it as a primary data file or you can call it as a master data file, sir, where your actual data is storing. Actual data is storing. Where your actual data is storing in the MDF file. Okay, that is a primary data file. You can call it as a primary data file. You can call it as a master data file. You can call it as a data file. Whatever name you are flexible, you can call it. When you create any database, two files will be created internally. Two files, one is a data file, one is a log file. Data file, you can call it as a data file. You can call it as a master data file. You can call it as a primary data file, where your actual data is residing. Now, what about LDF file? All the change related information, means whatever the modifications you are doing, whatever the changes you are doing, that can be insert, update, delete, alter, whatever the changes you are doing, all the changes, first it will go to the LDF file, then it will go to the MDF file. Please make a note down. This is very, very, very important. I will talk more on the next session, sir. Okay. All the changes, whatever the changes you are doing in the SQL Server, all the changes, first it will go to the LDF file. then it will go to the MDF file. First, it will go to the LDF file. Next, it will go to the MDF file. Okay, directly can I make changes in MDF file? No. No, SQL won't allow you to make any changes directly in the MDF file because that is our primary. So what exactly happening in the background? All the changes, whatever you are doing, right? All the changes first, it will go to the LDF file, then it will go to the MDF file. How it will move, what is happening in the background, we are going to learn in the next session, sir. Is it clear? As a DBA, first, once you install the SQL Server, your application people will request us to create the databases. We will create the databases and will grant the required permissions to perform certain activities on that databases. Whenever you create a database, by default, two files will be created. One is a data file, one is a log file. Data file contains the actual data, Log file contains the change related information. Whatever the changes you are going to perform, all the changes first it will register in the log file, then finally it will go for the MDF file. Okay, not okay. What is a database? Database contains the data which is arranged in the proper way, organized in the proper way, and easily managed, easily access, easily protect everything within that data, whatever the data which is available in that database. Now, there is one more file, sir, nothing but secondary data file. Where is my mouse? Okay, yeah. There is one more file like MDF. Okay, we can also create the NDF file, secondary data file. Okay, every database MDF file is a mandatory. By default, you will get the MDF file and it is a mandatory. Now, I want to improve the performance because see the uh, data is a massive in the real world. You will see terabytes of data in real world. In our laptop, you can't see, but when you go to the real world, you will see the terabytes of data. Now my database is growing, and my disk is also growing. Certain time my disk will get full, my data file will get full. Okay, to improve the performance, what I am going to do, I am segregating the data into the multiple files. Means half of the data I'm moving to the different file. Half of the data I'm moving to the different file to improve the performance. Or I am going for partition. Or my disk is not having compatibility to grow after 2 terabytes. So that I created new disk, I created a new file. What file I'm creating? NDF files. Okay, secondary data file. Secondary data file. You can create the n number of secondary data file. This is also data file only, sir. Please don't think it is a different. Okay, but you are technically calling is a second data file and technical naming. So what you are doing the extension dot ndf dot mdf dot ldf. That clearly you are mentioning the extensions. MDF master data file, LDF log data file, NDF dot secondary data file. You can create n number of secondary data file to improve the performance of your database whenever your database is massively growing. Okay. In the primary data file also contains the data. In the secondary data files also you are getting the data. Log file contains the change related information. Can I create multiple LDF files to go? Yes, you can create multiple LDF files. You can create multiple LDF files. You can create multiple MDF files. You can create multiple NDF files. You can create multiple LDF files based on your requirement. But by default, when you create any database, it contains only 2 files. That is nothing but one MDF file, one LDF file. Later on, if you wanted to create, you can create as many as you want. Got it, everyone? No? Yes? Question, sir? Yeah. Okay. Yeah. Great. I will back on architecture again. Okay. Let me discuss now. Now, next concept what we want to discuss is storage. Okay. We wanted to focus is the storage architecture. How internally our data is storing. Okay. Then you can understand how the data movement is happening internally when you are performing modifications. So our first focus will be storage architecture. Okay. Now, let's in SQL Server, your data is storing in the form of pages. In SQL Server, hey Subbu, just now you told that our data is storing in the files like MDF files, LDF files, right? Now again, what is this? Yes, sir. In that file where your data is storing, in the which format the data is storing. In SQL Server, your data is storing in the form of pages. In SQL Server, your data is storing in the form of pages. In the form of pages. Please make a note on your data is storing in the form of pages. Each page size is 8 kilobytes. One page size is 8 KB. One page size is 8 kilobytes. 8 KB. One page size is 8 KB. One page size is 8 KB. Everyone knows about the Word document, sir. Okay. Everyone knows about Word document. Don't say no. Okay. Many people knows about Word document. See, if I open the Word document, see, assume this is one page. This is one page where you can write some information. Like same, see, there is a header, there is a footer, there is a data. Correct? In the page, when you open the Word document, in the page there is a header, there is a footer, and there is a data where you can keep your data. Like same in SQL Server, in SQL Server also your data is storing in the form of pages where it contains header, where it contains footer, where it contains data rows. It contains data rows. Please make a note on it is a data rows. Okay. It is a header. It is a footer. Footer. Okay. It is a footer. So what information is available in the page header? Okay. Page header size is 96 bytes. Page header size is 96 bytes. Page footer size is 2 bytes. And data rows page is 8096, 8092 or 8096. The size of data rows. Okay, the size of data rows is 8096 or 8092, some value, sir. And page header is 96 bytes and row footer is 2 bytes. 2 bytes. It's not kilobytes also, 2 bytes, sir. Now, what information your page header is storing? What information your page header is storing? Your page header contains, okay, page information, page ID information, object ID information, okay, slots, okay, how many rows are available is nothing but slots. Next page, previous page, free space, allocated space, okay, and memory stack. This information will be available in the page header. Page header. Page header contains page ID, object ID, slots, next page, previous page, free space, allocated space. Okay. All that information will be available in the page header. Can I see Subbu? Yes, you can see the information. Yes, you can see. Okay, can I see the page header? Yes, you can see. So in SQL Server, your data is storing in the form of pages. Each page size is 8 KB. Can I increase? No. Can I decrease? No. Okay, you can't increase the page size. You can't decrease the page size. It is a fixed value. Now, how the page architecture is, Subbu, means every page contains the page header, page footer, and data rows. Okay, page header contains page ID, object ID, slots, next page, previous page, memory information, many more. Free space, allocated space, much more. Here, very important is page ID, object ID, and slot. Okay, slots means nothing but how many records are available in this page. Slots are nothing but how many records are available. Is it clear? First one, page header. Okay, okay. Now, data rows. Data rows, nothing but data, sorry, your data like one, okay. For example, Raj, 10,000, 2, 5, 5,000, 3, Aswini, 15,000, okay, 4, okay, John, 10,000, 25,000. So it is storing the data there in the data rows. data rows. Now, what about the footer? Data rows contains the data, header will contains the historical information, but what about the footer? What about the footer means? See, technically footer we are calling as a row offset. Technically footer is calling as a row offset. Row offset information is stored in the end of the page after the data row session. After the data rows at the ending row offset. Each data row having the row offset at the size of the row offset is 2 bytes. Means, see, simply assume you are inserting the data, updating the data, deleting the data. Simply, it can't go into the page, right? So row offset knows what sort of rows I am trying to load the data in this page. So row offset contains the record ID information for reference purpose. For reference purpose, row offset contains the your record ID information. Row offset contains your record ID information because simply it can't load the data right into the page. So somewhere it need to make a note down what sort of records it is arranging in the data row session. Who is going to maintain? Row offset is going to maintain all this stuff. So row offset knows what records are loaded into the data row session, and the row offset size is 2 bytes. And technically, you are calling as a row offset, okay, or you can call it as a footer. Don't call footers, or call it as a row offset only. This is about your page architecture. So in SQL Server, your data is storing in the form of pages. Each page size is 8 KB, which contains header or data rows, footer we are calling as a row offset. Header will contains the page ID, object ID, slots, next page, previous page, free space, allocated space, all that information. Data rows contains the data, and row offset contains the record ID information. And every record, how it is arranging means whenever you are inserting, updating, deleting, it will go from the footer only and load the data in the data row session. That is what happening in the background, sir. Questions. Very important interview question. Very, very important interview question. Clear? Not clear, everyone?
Clear.
Yes.
Subu, please, can you explain again about the row offset?
So row offset is nothing but footers are basically, see, for example, you are inserting a data. Examples. How it will insert into the page means from the footer. From the footer, it will try to load the data in the data rows. Till now clear? When you are inserting, it will go, it will try to insert the data into that page from the footer. From the footer, it will try to load. Now, when it is loading, it will track that information in the row offset. So your row offset knows what sort of records it is available in the data rows. Got it? No? Yes?
Okay, so we can say once the data is loaded inside the page, the row offset keeps a track of each
Record information.
each record inside the data page.
Yes.
For easy
Yes.
reference.
Yes.
Okay, thank you.
Very, very important interview question. Okay, everyone, please make a note on this. Is one important interview question. They may confuse us a lot. Someone is asking. Okay. Okay. Now, no, nothing. Everyone is clear, right? I'm good. Can I move to the next slide?
Subbu,
Yes.
data row size dependent on the type of the it's the varchar 2 or it's depend on that one.
Loading,
Data
sir. I will talk. I don't want confuse us a lot now itself. Okay. I will talk that point when we are discussing indexes. Okay. That time
Okay.
you are already strong in SQL. You can understand if I'm discussing a complex information. Okay.
Yes.
I don't want confuse us right away. Okay. I am just touching the high level. I will go deeper when we are talking on the indexes.
Okay.
Okay.
Yeah.
There are many things still I haven't discussed, sir. I'm just discussing only high level algorithm. Okay, I will talk more when we are discussing indexes. Okay, no worries. I will go to the data type. I will go to the size of the data type. How many records will fit in this page? Okay, and that will also we'll discuss. No worries. No worries. As of now. Yep. Now, next. Okay, there is a concept called extend in SQL Server, sir. Okay, there is a concept called extend in SQL Server. Just now we discuss about the page. Don't get confused. Here, many people will get confused, sir, but I am requesting, please don't get confused. Okay, your data is storing in the pages only. Your data is storing in the pages only. Please keep it in mind. This is very important. Where your data is storing? In the pages only. Your data is storing in the pages. Please don't get confused at all. Okay. Now, but what Microsoft done? Microsoft make one more layer called extend. One more layer extend. Okay, called extend. So what is the extend? 8 continuous consecutive data pages, will call it as a one extend. 8 data pages. 8 pages. Okay, leave it about. 8 pages, will call it as a one extend. One extend. And the size of extend is 64 KB. And the size of extend is 64 kilobytes, because each page size is 8 KB. 8 into 8 is nothing but 64 kilobytes. 8 into 8, nothing but 64 kilobytes. So don't get confused. Your data is storing in the pages only. But what Microsoft done? Microsoft created one more layer called extend. One more layer called extend. Okay. What is extend? 8 continuous consecutive pages, will call it as a extend. One extend. Okay. Each extend size is 64 kilobytes. And we are having two types of extends. One is a uniform extend. One is a mixed extend. One is a uniform extend. One is a mixed extend. What do you mean by mixed extend? If 8 pages contains different object data, if 8 pages contains different object data, then we'll call it as a mixed extend. If 8 pages contains single object data, then we'll call it as a uniform extend. Very simple understanding, sir. Okay. On top of the pages, there is one more layer in SQL Server, that is nothing but a call extend. Okay, extend. To understand more, the first time who are listening SQL Server, to understand more, I will give you one simple hint. Okay, you will install a SQL. You will install SQL. Okay, once you install a SQL, you will create a database. When you create a database, background you are getting a files. Nothing but MDF files. Okay, NDF files and LDF files. Okay, in the files there are extents. In the extents there are pages. In the pages there are rows. Means nothing but records. I hope you got my point. How your data is storing, how your record is storing in the pages. Where the pages? Extents. Where that extents? Data files. Where the data files? Database. Where is your database? In the SQL instance. Low level to high level to low level. Everyone understood? Yeah, everyone understood, sir. Now see, don't get confused. Your data is storing in the pages only. Please, sir, don't get confused at all. Okay, pages only. But what is the hierarchy you need to remember? Okay, I am installing SQL Server. Oh, my job is done. No, I need to create a database. Okay, what is happening when I create a database? Files are creating. In that files, what is available? Extents. In that extents, what is available? Pages. In the pages, what is available? Rows or keys. Rows or keys. Keys is nothing but indexes. When you create the indexes, there is a key concept. If you're not creating indexes, only row concept, sir. Row concept. So this is the hierarchy from high level to low level to high level. If you understand this one, You are super good at data storing. You are super good at data storing, sir. Anyone having any questions? What is extend? 8 continuous consecutive 8 data pages will call it as extend. Okay, 8 pages will call it as extend. What is the size of extend? 64 kilobytes, because each page is 8 KB and totally 8 into 8, 64 kilobytes. How many types of extends are there? 2 types of. One is mixed extend, one is uniform extend. What do you mean by mixed extend? If 8 pages contains different object data, then we'll call it as a mixed extend. If 8 pages contains same data, then we'll call it as a uniform extends. Question, sir, in this slide. Very, very important. You need to understand. Yes.
So in uniform extend, is it of same object pages or different tables pages?
Only same object, ma'am. Same
A
object.
single table, right?
Single table. Single
Yeah,
table.
yeah. Okay, thank you.
You will understand, because this is the one confusion. Many people having one confusion. How we need to understand the hierarchy means this one, ma'am. See, there is a application. Okay, it can be home loan, it can be personal loan, it can be car loan, it can be insurance, it can be banking, anything. Your application is pointing to the OS where your SQL is installed. In that OS, it contains the SQL. In that SQL, it will contains the database. In the database, it will contains the files. In the files, it contains the extents. In the extents, it will contain the pages. In the pages, it will contains the rows or it will contains the keys. Got it? How the mapping is happening from the application to low level, where that data is storing. Where you are, see, for example, take your SIM card. I got chance to work in Idea. Who are in India, you can understand Idea. Everyone knows about Idea previously. So we can go and verify what is your name, what is your mobile number, what is the plan, when it is going to expire, what is the last call, how many seconds you have talked. Okay, we can get all that information when I go to the database. Okay, so now your application is pointing to this database. Okay, this database. So you need to get the right database name, otherwise you can't see the data finally. Okay, will I store all the information in single database? No, sir. No. Everything in real world. See, car loan is one project. Home loan is one project. Bike, health insurance is one project. COVID insurance is one project. Everything is a single separate projects. They are maintaining separate application. They are maintaining separate policies. Okay, they are maintaining separate enhancement. So think high level, sir. You should not think low level. Think high level. See, you are having issue. For example, I am working for ICICI Bank. I am working for HSBC Bank. HSBC Bank. If I am having issue, I will directly go to the HSBC CEO. Oh, I am having some issue. No, I never go to this client. Who is your primary contact application? Who is your primary contact application, sir? For us, who is the primary contact application team? Who is maintaining this home loan, car loan, personal loan, health insurance, home insurance? Okay, to this. So whom you are contacting? To the application team. Who is our primary contact? Application team, not HSBC CEO, HSBC people who are working in the bank. No, you never contact them. To whom you will contact? The people who are maintaining these applications. Those people are our primary contact. Those people are our primary contact. Now see, you are working in a bank or in a somewhere you are working, sir. You got one idea which is not available in this client. For this client, there is nothing that policy. Now you went to the leads who are holding this one, and you will explain. I got one idea which is not yet implemented in this project. Okay. Now for that idea, I want couple of servers. Okay, I want dev servers, I want test servers, I want prod servers. What developer will do? developer will start developing the project. Once development is done, it will go to the testing. Once the testing is done, will go to the production. Until it will go to the production, you can't see the data. Okay, to make little simplified. Okay, everyone is maintaining the smartphones, right? Everyone. So you have installed games, you have installed WhatsApp, Facebook, okay, Twitter, Instagram. Many people are maintaining. Now your Instagram, your WhatsApp, your Facebook, they are updating something in version to version. You are getting some updates. Until unless you update that product, until unless that product come into live, you can't see the changes in that application, right? Yes or no? Everyone, yes, no? Once that update is released and that update you installed, then only you can see that changes in your application. Like same, developers are doing development, testers are doing continuous testing. Once everything is done, then it will come to the production. Until it come to the production, you can't see the changes. So if I'm having any idea, then I will start doing this one. Okay, I need this many servers. I need this many SQL instances. Okay, I need this many DBAs for my testing purpose. So now the project is starting. Now for this you are supporting. For whom you are supporting? Of course you are be part of SSB only, HSB only, but you are not supporting entire HSB clients, sir. You are supporting only 20 applications, 30 applications, 40 applications, 50 applications. Okay, where these applications are posted in SSBC only. So you are not dealing with whole HSBC client. Or don't think that, okay, I'm working for HSBC or I'm handling everything in HSBC. Nothing. No, you are absolutely wrong. Assume you are having 200 applications. Okay, 200 applications. What do you mean by application? Car loan, home loan, personal loan, health insurance, medical insurance, COVID insurance. These are applications. Okay. Now each applications, assume 200 applications, 50 applications are relying on the SQL, 20 applications relying on the PostgreSQL, 10 applications relying on the MySQL. Okay. 35 applications rely on Oracle. Now your support is this. Okay. Now 50 applications rely on the SQL. Now for these 50 applications, you are having dev, test, pre-prod, prod environment. How many servers we are maintaining? We don't know. How many applications you are maintaining? 50 applications you are maintaining. Under the 50, you are maintaining 100 servers. For example, like 50, make it as a 3 by default. 3, like a dev, test, prod. Like 150 servers you are holding. 150 servers you are holding. 150 instance you are holding. How many databases we are maintaining? Literally many, sir. Many. Okay. Within one instance, you can create multiple databases. So in this instance, we can maintain multiple databases. In that databases, files. In that files, extents. In that extents, pages. In that pages, rows. Got it? Everyone? No? Yes?
Yes, sir, got it.
No, sir. So extents is very important. This is also one of the most important interview question. What is extent? Definitely they may ask you question. Okay. Extent is nothing but 8 continuous databases. We'll call it as a one extent. In SQL Server, we are having two types of extents. One is uniform extent, one is mixed extent. If 8 pages contains single data, single object data, then we'll call it as a uniform. If 8 pages contains multiple object data, then we'll call it as a mixed extent. Okay. Now next slide, sir. If you don't have a question. In SQL Server, we are having different pages. Okay. In SQL Server, we are having different pages. Like in SQL Server, we are having two varieties of extents. Like say, in SQL Server, we are having different types of pages. Now, totally, we are having 10 pages. 10 pages. Database, GAM page, SGAM page, PFS page, DCM page, okay, BCM page, IM page, boot page, text page, image page. Total almost 10 pages are available in SQL Server. Will I need to remember all this stuff, Subbu? Yes, you need to remember. There is no other choice for us. We need to remember, sir. Definitely, they may ask you a question, how many varieties of pages are available in SQL Server? So, database, GAM page, SGAM, PFS, DCM, BCM, IAM, boot page, text page, image page. Total overall 10 pages are available in SQL Server. And each page is very important because each page is doing unique, each page is taking unique responsibility. Each page is taking a unique responsibility. We must and should know, okay, all the pages functionality. Okay, today our focus will be data page, GAM, SGAM, PFS page, sir, boot page, text and image page. I am not discussing IM page. I am not discussing PCM page. I am not discussing DCM page. Okay. I am not discussing these 3 pages. When I am talking backups, I will talk on DCM page. Okay. Backup. When we are discussing backup, I will talk on DCM page. When I am discussing recovery models, I will talk on BCM page. When I am talking index page, I will talk on the index. When I'm talking index concept, I will talk on the IAM page. So except these 3 pages, I will talk all the pages. Is it clear, everyone? No. Yes.
Yes, sir.
Okay. Now first, by default, there is a database, sir. Don't get confused at all. Okay. Where your data is storing in the data pages. Where your data is storing in the data pages. A blind answer, sir. You no need to get any confused. Where your data is storing. In my SQL, my data is storing in the data pages. In the SQL, my data is storing in the data pages. It's a blind take. There is nothing second choice, all the stuff. Where your data is storing, our data is storing in the data pages. Now, this is the 2 very, very, very important entry questions. Okay. These 2, where is my notes? Come on here. Okay. Sorry. Okay. Hey, come on here. Okay. So database contains the data. Okay. We don't need to discuss much about database because it contains the data. Just now we discussed about database architecture also. Now we wanted to know about GAM page, SGAM page. Very, very, very important. So try to understand the logic because whenever you see the slide itself, it contains lots of data. It's very difficult to remember, to read all the stuff, sir, because in our day-to-day busy life, definitely we may forget many things. What I wanted to convey to you, right? If you understand the logic, you can just explain the logic. They are happy. Your interview is happy. Just understand the logic. Don't see the theoretical part. Okay? Don't see the theoretical part. You need to understand the logic. Okay? Just try to understand the logic. For example, assume user. Okay? Assume where is my mouse is disappearing every time. Okay. Now, for example, okay, Supriya is trying to perform one insert, for example, insert, okay, or she's trying to create a table. For example, she's trying to create a table or she's trying to perform insert operation. She's trying to perform the insert operation or she's trying to create a table. Now, what is happening background? Try to understand. Now, when you are trying to insert, when you are trying to update, when you are trying to delete, so you need the pages. You need the pages. But in the database, what is the first hierarchy? Extents. Under the extents, only the pages. Under the extents, only the pages, basically. Extents, under the extent, there is a pages. First, for Supriya, SQL Server need to allocate the extents. SQL Server need to get the extents to this operation. Okay, you need the extents. Now, where it will get the extents? Who will allocate the extents to Supriya's operation means GAM page. GAM page, global allocation map. Okay, global allocation map will allocate the extents. Who will allocate the extents when Supriya is going to perform insert, when Supriya is going to perform creates, when he is going to perform insert, when he is going to perform creates, who will assign the extents to the Supriya's operation means GAM. So GAM page will allocate the extents to this operation. How many extents it will allocate means based on your operations, sir, means based on how many inserts you are going to perform, how many massive inserts you are going to perform. Based on that, your GAM page is allocating the extents to that operation, to that insert, to that create, to that operation. Now, okay, I understood. Okay, I am getting extents from the GAM page. First, I am getting the extents from the GAM page. Now, how many extents will GAM page will hold? 64,000 extents will 64,000 extents will be available in the GAM page. 64,000 extents information will be in the GAM page, and the size is 4 GB. Each GAM page size is 4 GB. Each GAM page size is 4 GB, and it contains 64,000 extents information. Each GAM page size is 4 GB and it contains 64,000 extents information. For example, Supriya is going to perform a create. For this create, SQL Server allocated 10 extents. Okay, based on the structure of the table, assume SQL Server will allocate 10 extents to the create table. For this employee table, 10 extents has been allocated. Now, GAM page will hold 64,000 extents, right? Now, 10 extents has been allocated to employee table. Now, how many are available? 63,990 extents are available. Okay, 63,990 extents are available. For example, Ramesh is going to perform one insert. Okay, for this 150 extents is needed. Now it will get from here 63,700 840 because 10 is already allocated. Now 150 is already allocated. 63,840 extents are still there. Now 150 extents will be allocated to this insert operation. Now someone is performing until this 64,000 extents completed. It will get the data from this GAM page only. Okay, Subbu. Assume I am using overall 64,000 extents. Again, next what will happen is it will create one more GAM page. It will create one more GAM page. And that GAM page will contains again 64,000 information. 4 GB it will store. I hope you are getting my point, everyone. No? Yes? How the allocation is happening? But I am having little confused. I am working at DBA. I am having little confused. If I go to my database size, my database size is just 272 MB. You are saying that my GAM page size itself is a 4 GB. Okay, my database size itself is a 272 MB only. Then how I can trust you, Subbu? You are saying that my GAM page size is 4 GB. It contains 64,000 extents information, but my database size itself is a 272 MB only. What is the logic? Okay, sir, it is not a static, it is a dynamic. Please make a note on. There is a concept called static and dynamic. Anyone knows about what is static, what is dynamic? It is not a fixed length. It is a dynamically growing. So when you are using, it is growing. When you are using, it is growing. When you are using, it is growing. So being the usage is massive, your growth is also massive. See, for example, you created a one test document, sir. Come on here. You created a one test document. Okay. Now currently when you go here property, what is the size here? 0 bytes. Okay. Now what it will do when you start loading the data, assume when you just start loading the data. Okay. When you just start loading the data, if you go to the property, you will see some size, correct? Agree, not agree? Okay, statically it is growing. So dynamically it is growing. It is not a static. Now what it will do if I'm paste, again copy. Okay, again paste it. See the growing characters are growing. Definitely the size will also grow. Okay, now save it. Now go and verify the size of this file. Okay, the massive. The size is growing. Now I can again load the data, copy whole. Okay, and paste it. Again copy, again paste it, save it. Okay, now go to here, go to and verify the size. The size has been let's it will take some time. Refresh. Let's go to the property. Oh, not done. Oh, we not saved. Oh, come on here, I not saved. Save. Okay, save. Close it. Now go and see. Obviously the size is increased. That is how the database is working. That is how the database size is working. It's a dynamic. Okay, it's not a static. It's not a static, it is dynamic. When you start loading the data, okay, the GAMs are working, SGAMs are working, databases are working, everything is working. It is not a static, it is a dynamic. Is it clear, everyone? No, yes.
Sir, can you give me example for the static?
It's a fixed, sir. It's a fixed length. It's a fixed length. If I go here, see, if I'm restricting, so here currently I'm not restricted. So for example, currently I'm not restricted anything. For example, if I'm restricting the memory, okay, statically I'm telling that, okay, my memory should grow to 248 only, 2 GB only. It should not grow more than. Okay, if I'm not allocating this one, now it will grow up to max size, right? It will start using from zero to it will grow it until the usage it will grow, right? I am not statically passing the information. Dynamically it is growing. So there is no concept called static in terms of growth, sir. In terms of this allocation, there is no concept called static. It's a dynamic only. Here there is no concept called static. It's a dynamic only. Okay, it's a dynamic. It's a dynamic. Please keep it in mind. It's a dynamic. Very important. So it's a dynamic allocation. Now you will get one doubt. Okay, so both dynamically the extents are allocating. So to Supriya it is got allocating. To Ramesh it is allocating. To Raz it is allocating. Everyone it is allocating. How I will get to know how SQL knows that how many extents are allocated, how many extents are still free. Like it is a binary value, sir, 0, 1. The GAM has a bit values. Okay. If the bit is 1, the extent is free. If the bit is 0, the extent is allocated. That is how SQL is tracking internally. SQL is tracking internally. If the bit is 0, the extent is allocated. The extent is allocated. If bit is a 1, extent is free. That is how SQL is tracking the information. SQL also need to track the information, right? Simply it can't allocate. So it need to track somewhere how many extents are allocated. Out of this 64,000, how many extents are allocated? How many extents are still free? It need to track that information, right? Agree? Not agree, everyone? How it is tracking? By the value called bit value, binary value, 0, 1.
Yeah, excuse me, so can you explain again? I don't understand what it means by if the byte is 1, the extent is free. If the byte is 0, the extent is allocated. I don't really
Out of
understand.
64,000 extents, okay,
Yeah.
assume just now Supriya created one table, SQL allocated 10 extents to that, right? Okay, out of 64 extents now, how many are free? 39,990 extents are free, correct? All
Correct.
that value will be set as a 1 because those
Okay.
are free.
Okay.
Okay. Now, whatever the extents allocated to Supriya, 10 extents, that byte value is a 0.
Mm,
No? Yes? The bill. See, somewhere it need to track, right? Otherwise, how it know that all my 64,000 extents are allocated? Somewhere it need to track, right? I hope you are
yeah.
getting my point.
Yes.
How the tracking is happening means, if the extent is no one is using, means it is not using, sir. Allocating. Sorry.
Yes. Allocating.
If the extent is not allocated, the binary value will be 1. If the extent is allocated, the binary value is 0.
Okay. Okay. Okay.
Not using, sir. I'm so sorry. I'm taking back. Okay. Yeah.
Okay.
Now, okay. This is the GAM page. Now, whether the extent is allocated or extent is free. Now, sir, simply, for example, take this is what happened? 1 second, sir. Uh, hey, where it is? Okay. Is there any background or some process which take care the GAM page allocation? How come that now? See, I told you, right? There are multiple algorithms which are working in the background. Okay, which are working in the background, and the how Microsoft design means when you are when you are doing something in SQL Server, definitely you need the extents. You need the extents. Now, what is happening background? It is going and it is getting that extents and allocating to your operation and try to load the data. But see, that's what waits are still we haven't discussed much more. We wanted to know much more here. Extents concept will be available only at the database level. Okay, when you go for buffer, just know we discuss buffer. Okay, like a buffer manager. In the buffer manager, there is a buffer pool. In the buffer pool, there is a data cache. Okay, there is no concept called extent in the buffer. Please, nothing. That's what, sir. Hold on. Okay. Uh, we wanted to know more. That's the one thing. 10 days why we are spending here time is in SQL, especially in SQL, we wanted to know internals basically. Okay, internals, more internals. What is happening in the DB level? What is happening in the buffer level? Extend concept will be available only at the DB level, not at the buffer level. Buffer level, there is no concept called extend. There is a concept called page. That's it. There is a concept called page. Now, whenever, that's what I will tell you tomorrow when you are performing business operation, inserts, update, deletes. Uh, is it clear what I wanted to convey? I can't explain everything at one shot. There are many things, sir, many things. Okay, being we are a DBA, we must and should know all the things so that you will become strong in troubleshooting, especially. So I will explain tomorrow, next session, how business operations are performed, like inserts, update, deletes, what exactly internal is doing. Today, what I wanted to convey is how these pages are working. How these pages are working. GAM page. Okay. How GAM page is working. Every GAM page contains 64,000 extended information. Each GAM page contains 4 GB. and how it is SQL is making a note in the form of bit value 0101. If extend is used, it will make it as a 0. If extend is not at use, allocated, it will make it as a 0. 1. 1 by default is a 1 only, sir. By default 1 only
Sir,
because, yes.
I want to ask something. Like you're saying there are 64,000 extents.
Yes.
Means as I create something like a page or something like that, it will automatically create one to like up to the 64. After completing 64,000, it will automatically create the another GAM page. Yes.
See, okay, see, sir. For example, you create one database. Okay, you created one database. Okay, database. Now, when you just started creating a table, okay, how the mechanism will start. For example, you just started creating a table. So to create a table, definitely this database need to allocate the extents. Okay, extent need to allocate. Now what it will do, it will first, to create the table, first it will go to the GAM page, get the extents and allocate some extents to the table.
Okay.
So it is going to the extent first, it is going to the extents and getting the extents and loading the data into that extents. Just I created a table. Okay, assume 5 extents has been allocated, 4 extents has been allocated, 10 extents has been allocated. Now, for example, you start inserting the data. What it will do, directly it won't get the pages into the buffer to insert the data. How the pages are getting from the GAM page only. How the pages are getting from the GAM page. When you are inserting the data, first it will go to the GAM page. First it will go to the SGAM. See, there are multiple. We haven't discussed next concept. I am explaining only how the allocation is happening, where that allocation is happening from the GAM page. From the GAM page, the allocation is happening. How the algorithm is working? Wait, sir. Wait. Okay, still haven't discussed many things. How the allocation is happening, where the allocation is happening, X GAM page only. So GAM page is responsible to allocate extents whenever you need based on your operation. Based on your operation, if you need the extent, your GAM page will allocate the extent to the respective process. Is it okay? Not okay? Everyone.
Okay, sir. Yes, sir.
Okay. Great, sir. Now, see, just now I told that allocation is happening. Okay, one extent is used. If it make it as a 0, if its extent is not used, it will make it as a 1. Now, what is the extent? 8 pages, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 pages. Can you guarantee that 8 pages contains fully of data? Now you just created a table, sir, and you just started inserting the data. You inserted only one record. Okay, you inserted only one record. Will that one record will store 8 pages? No, right? It's absolutely wrong, sir. Okay, assume it contains one record A1, ABC, okay, and 10,000. So it stored one record, but for this insert, it allocated one extent. For example, in this extent, it stored only one record in the one page. In this page also there is a free space. In the extents also there is a free space, right? In the extent also there is a free space. In the page also there is a free space. In the page is also there is a free space. In the extent also there is a free space. Now someone need to track that information, right? Someone need to track that information. Is there any free space available in the page? Is there any free space available in the extent? Agree, not agree? Yes or no? Someone need to track. Someone need to track any space available in the page, any free space available in the extent. Who is tracking this information? SGAM, PFS space. Now you will understood. Allocation is happening from GAM page. It is allocating the extents. But how I can guarantee say that my page is completely filled with the data, my extent is completely filled with the data. Otherwise, we are wasting storage, sir. Assume, sir, if you are simply allocating and you are loading the data here, and 5 pages are free, and in this page also there are some free space, and you are not loading the data, again it is allocating one more extent, it is loading half of the data, again it is, you are wasting storage. Hey, storage is very important for us. What Microsoft is doing, okay, let's allocate extent. Okay, then I can track using SGAM. I can track extend free space information. Using PFA space, I can track page free space information as well. Then in future, if you are inserting the data, I will use where my extents having free space, right? I will start loading the data here only. I am not allocating new extent for you. If there is extent is already allocated, in that extent there is a free space, let's start loading the data in the free space first. Then if that complete free space is completed, then again I will go for the GAM page, get the extent for you. Got it, everyone? Unless your extents got filled with the data, you won't get the new extent for you. No, because storage is also very important for us. Storage is also very important for us. Not getting, sir? What SGAM is doing? SGAM is tracking whatever the extents allocated for you, right? Whether that extents is having free space or not. Who is going to track? SGAM is going to track. GAM is allocating the extent to you. GAM is allocating the extent to you, but SGAM is tracking the information. SGAM tracking that so and so extent is allocated for so and so object. Okay, in that extent still there is a free space. Let's start load the data. Sir, in the background, not only SQL, many database engines are doing many things in the background. We are simply seeing that, okay, inserting the data, updating the data, deleting the data. Background, this many things are happening in the less than nanoseconds. Background, these are happening, sir. So what is the role of SGAM? SGAM will track the extents allocation information. GAM is allocating the extent. SGAM is tracking the extents free space information. Extends free space information. What is the SGAM size? It is also 64,000 only. And what is the SGAM size? 4 GB only. But there is no data here. This is just information. Again, sir, in reality, we never go deep dive this all stuff in real world. Okay, we are doing our work only. But as a DBA, you need to understand what is happening in the background when I'm trying to perform insert, when I'm trying to create a table. What is happening in the background means these many processes are running in the background. Your engine is taking many responsibilities. All this. Got it? No. Come on, sorry. Everyone need to raise your voice. Many experienced people itself
Yes,
will
sir.
have lot many questions here. I am trying my best to clarify you. What is SGAM is doing? SGAM is tracking whatever the extents allocated by the GAM page. Okay, whatever the extents allocated for the GAM page, that extends free space information is tracking by the SGAM. SGAM is tracking free space information. How it is tracking? Okay, how it is tracking? See, if the GAM page one, like a 1 only, 1 0 only. If the bit is 1, the extent is being used as a mixed extent and having free space. If the extent is the bit is a 1, okay. Here, if the 1, it is a free. The extent is not yet allocated. If it is a 1, it is used and having some space. But if it is a 0, bit is a 0. If it is a 0, The extent is, okay, see, the extent is used. Oh, sorry. If the bit is 0, the extent is not used as mixed rate. Okay. Yeah. So if extent is 0, means the extent is completely filled with the data. There is no space in that extent. In that extent, there is completely filled with the data. There is no free space. The extent is not used as a mixed extent, or it is a mixed extent and all the pages have been used. To clarify more, I'm simply saying that if it is a 0, the extent is completely filled up with the data. If the extent is 1, okay, the extent is allocated but having some free space. Next time when you are inserting the data, first it will try to update that information in this extent. Then if everything is filled, then it will go to the GAM page, get the pages. It's an internal algorithm. It is an internal algorithm. We can't see it. Okay. Whatever you are doing, it's happening in the background, sir. Can I see GAM page? Yes, we can read the GAM page. We can read the SGAM page. Okay, I will show you how to read that pages as well. How to read those pages. But precisely to understand more, very important is DCM page, BCM page, sir. Basically, BCM page. These are very important. These two pages. But from interview point of view, as a DBA point of view, these two are very important. These two are very important. Most of the people will get confused in the GAM page SGAM. Very simple. Allocation is happening from the GAM page. Allocation usage is happening from the SGAM page. That's it. Apart from nothing else. Don't explain all this to the interviewer. If someone is asking, what is GAM page, what is SGAM page? So how I will explain is GAM stands for Global Allocation Map. SGAM stands for Shared Global Allocation Map. Both are working with the extents, okay? GAM page is allocated in the extents whenever user is requesting, creating, inserting. As GAM will allocate the extents, and each GAM page size contains 64,000 and size of 4 GB. So SGAM will track the extents allocation usage information. Okay, this SGAM size is also 4 GB, which contains 64,000 information, 64,000 extents information. Okay, the value it is tracking as a binary 0101. Okay, if a 1 it is used but it is having some free space. If it is a 0, it is completely filled with the data. That is how simply I will explain to the interviewer. That's it, sir. There is no concept in the buffer. If you go for buffer, there is no concept called extend in the buffer, sir. In the extend, there is no concept called buffer. The buffer, there is no concept called extend. Please make a note down. We discuss much more in the cache. Okay, data cache. In the data cache, will the extents is there? No. Extents are only strict with the database level. Extents are strict with the only database level. Please try to understand. These are very important. As a DBA, we wanted to know all this stuff. It will hectic only. Again, I'm told you, right? First 10 days are little hectic. You need to understand the theoretical part. Every DBA need to understand the theoretical part. You can go deeply, sir. Again, if you start searching in Google, we can get n number of things than this one. But I felt that this is quite enough for us to understand what is happening in the background. Any questions? Anyone? No? Yes? Understand? Not understand?
Yes, I understand.
Now, finally, there is a page called, I will show you, sir. Okay, next demo, I will try to reproduce it. Like today, I hope you got my point, right? How the parser is working, how the semantic checks is working, how to see that semantic checks, how query tree to display, how the query tree internally, where the query tree is storing. Will you go and read all this stuff, Subbu? Means no, sir, in real world, in our busy life, no. But as a DBA, we wanted to understand, sir. Okay. Now, there is a concept called PFS page. Okay. And the first page is the PFS page only, sir. The first page is a PFA space. In terms of something you ask one question, right? See, first page is a PFA space, PFS space, SGAM, GAM, and some other pages, database. Okay, finally there will be boot page in the data files. Okay, it is following the algorithm. It is following the algorithm, sir. It is following the algorithm. Internally, SQL Server is following algorithm like PFS, GAM, sorry, SGAM, GAM, SGAM, database, boot page. Internally, there is an algorithm. Internally, if I go deep dive, there is algorithms internally. There are thousands of algorithm Microsoft written. Okay, we can't go and see all the algorithms. But as a DBA, we wanted to know how that allocation is happening, how that space is means when you are doing certain things, insert, update, delete, create, all the things, there is a flow. First page is a PFS page, GAM page, SGAM page, data page, boot page, all that information here. Okay, based on that, the allocation, okay, loading is happening. The allocation load is happening internally. SQL Server is following the algorithm. Internally, SQL Server is following algorithm. What is that algorithm? The first page in the MDF file, in the data file, not MDF file, sir. I mean to say in the data file. In the data file, the first page is a PFS page. Every object, it contains one PFS page. Every object it contains one PFS page, sir. To track about that object information. Every object it is contained one PFS page. Every object, we are creating multiple objects. Objects in the sense of tables, sir. Okay. So first page is your PFS page, which is tracking free space information of all our data pages. Okay. It is tracking free space information about all the pages. Just now we discussed about the extent. Extends free space information, it is tracking. Now within that extent, there are pages, right? Pages. Now who is tracking that page information, Subbu? Means this PFS space. This PFS space is tracking free space information in the form of percentages. In the form of percentage, it is tracking, sir. Like 1 to 50% is full, 51 to 80% full, 81 to 95% full, 95 to 100% full. Your PFS space is tracking every database information. Of course, just now you told, right, Subbu, databases also contains the free space information. Of course, every page is tracking free space information. All the data pages free space is tracking by PFS space information. Your extents free space is also tracking by SGAM information. SGAM. These many things are happening, sir. PFS space is tracking all the database free space information. Each page is tracking free space information. All the database free space information is tracking by PFS space, and extents allocation free space is tracking by GAM page. Microsoft need to protect the data usage unnecessarily. We don't want waste the storage. So Microsoft is tracking these many things to look before load the data to the where the space is available. Space is available. Let's load the data. So PFS space, database, SGAM is tracking the free space informations. Who is going to allocate? GAM is allocating. GAM is allocating. What is GAM is allocating? Extent. What that extent contains? Data pages. Where, how the tracking is happening? SGAM is tracking. PFS space is tracking. Individual database is also tracking the free space information. When it start loading the data, all this mechanism will work together as a unit and load the data in a less than nanoseconds. Got it? No? Yes. Okay, I am not talking about DCM page, BCM page, IM page, sir, because you already having a confused now. I don't want you overload. Okay, now itself, I am stopping here. Any questions? Over to you, sir, now. Any questions? Understand, not understand? You learned something new, everyone? No? Yes? If you're not, sir, over to you. Done. My part is done. Over to you, sir.
So here GAM and SCAM are for tracking the complete extent, and the PFS is just at the page level, right?
Yes, ma'am. Like
Individual page
SCAM
level.
is tracking the usage. PFS is also tracking the usage. Even each page will also track the usage. See, we should not waste the storage. Correct?
Right.
We need to pay. So we should not waste the storage. Okay, allocation is happening from the GAM. Okay, allocation is happening from the GAM. What the GAM is doing? Allocating extent. What is that extent? Data pages only, right? Data pages.
Yeah.
Now this extent is allocating. Now this extent is having some free space or not? Who is tracking? GAM page. What about the data pages? PFS. Okay, and each page is also tracking the free space information. Many background processes are running in the background. Is it possible to perform demo on all the page types as well later? Yeah, I will show you. No worries. I can't tell you. I'm not showing. I will show you demo as well, sir. Okay, no worries. But precisely what I mean to say, still, even I will also get some confused, sir, sometimes, because in real world we won't do all this stuff. When I'm training to you only, I will explain all this stuff. Of course, okay. When I'm training to only, I will go to the slide. I will explain all this stuff. In real world, can I do all this stuff, Subbu? 99.9% you never do all this stuff. Sorry, to everyone, ma'am, you won't do. But as a DBA, we need to understand. I will show you demo, Wilson. No worries. Without demo, how I can say that? Okay, you understand. I will show you how to read the GAM page, how to read the SGAM page, how to read the page, how to read the DCM page, how to read the PCM page, how to read the IAM page. I will show you all the how to read it. Okay. What I wanted to convey today is, as a DBA, we need to understand the hierarchy. You are saying that, okay, I am just opening the SSMS, I am inserting something, I am updating something. Oh, my job is done. But what SQL is doing? SQL is doing these many things in the background, sir. Got it? No? Yes? Okay, yeah, that's it, sir. If no questions, have a great weekend. Enjoy your weekend, okay? See you on Monday. Yes.
Do we cover that like the scenario GAM congestions or these type of problems?
Sir, again, see, there are two things. Please, everyone, don't take negative on me. I am telling in the starting itself, everyone, okay?
Yeah.
Wherever I wanted to show you demo, definitely I will show you, sir. Means wherever I wanted to stress, I want demo, I can show you. Wherever it's okay, I won't show you, sir, because to prepare the demo is not easy. Okay. And one more thing, I told you, right? How many days I wanted to spend to you? 3 months. My plan is 3 months. I am having one algorithm. So 4 to 5 days I need to spend internals. Okay. 4 to 5 days I need to spend in the records, backups, recovery models. If I'm lagging here, definitely you may miss in advanced level. I hope you're getting my point. At any cost, I need to complete in 3 months. 3 months. Okay. Wherever I want to stress, I will stress definitely. Being you are not asking also, I will stress. Wherever I need it, you need it. Okay, I will stress it. Wherever I felt that, okay, theoretical part is okay, we don't want to do all this stuff because in real world, we know we won't go. See, as a engineer, as a IT engineer, you also need to do some homework. I also need to do some homework. Oh, you are giving amount to me. I need to show you everything. Definitely, if I'm lagging here, definitely you may miss in the performance tuning. I'm promising you in the day one itself. Now starting phase. If I'm lagging somewhere here, definitely you may miss the tunings. I need to concentrate more on the tuning, sir. And of course, this is also very important. I'm not denying to you. Wherever I wanted to search the demos, I told you I will search the demos on DCM page, PCM page, because these are very important concept. You need must and should. I need to show you this one. I will search. GAM base is GAM base. Not that much. I don't want, sir. I don't want that much. I don't want that much. Maybe I can go for theoretical part. Okay, someone won't accept, someone accept, but that's what I wanted to say. In the span of 3 months, now see how I wanted to train you, how much knowledge you wanted to gain. You can think, sir, whether Subbu is wrong, Subbu is right. You can make the decision. I'm absolutely agree for it. It's very difficult to show you everything demo. That's what I'm promising. But wherever I want to show you demo, definitely I will show you demo without you are asking, because those are very important concepts. Something I will show you theoretical part. You need to go on practical. You need to research. In the future, whenever you are having some time, you also need to do some homework. Not only Subbu, sir. Not only Subbu, even Raz also need to do homework. Wilson also do the homework. Ramesh also need to do homework, sir. That is what my training is. Are you accepting with me, everyone?
Yes, Subbu.
Are you accepting?
Yes,
Everyone,
sir.
I'm asking.
Yes, sir.
Yes.
That is
Yes.
what my trainings are. Because if I lag here, definitely you may struggle in the performance tuning. Because I'm telling in the straight away today itself, performance tuning itself will take 15 to 20 days for me. Always on will take 20 sessions for me. 20 days I will always on. 20 days performance tuning. 1 week migration. 1 week Azure SQL database. Now tell me how many days we done. How many days we completed, sir? 20 days for always on availability group. 20 days for performance tuning. Almost 40 days is done. Out of 90 days, 40 days is done. Then 1 week means 7 days for migrations, 7 days for Azure SQL database, 14 days. So 55 days we are completing with this one. Now how many days are pending for us? 35 days. 1 week I need to stick with the replication, because replications are one of the most toughest to concept in SQL Server. 1 week for replication. Then remaining concept, and again the 2 weekends, there is a Sundays. Okay. Now think all that one, sir. Okay, everyone, don't think that Subbu, you still not at give. Let me stop the recording, sir. I can talk off the recording.